In the words of Kastner and Newman, mathematics is a science which uses easy words for hard ideas. Now let us define median of a triangle. In a triangle, ABC, median of a triangle is a line segment joining vertex to the midpoint of the side opposite to that vertex is called median of the triangle. Here AD is the median. In this triangle ABC, AD is a line segment joining vertex to the midpoint of opposite side of that vertex. So AD is median of this triangle. Let us define median of a triangle is a line segment joining vertex to the midpoint of the side opposite to that vertex. Midpoint of the side opposite to that vertex. In this triangle ABC, AD is one of the median. Now, I am taking triangle ABC. In triangle ABC, D is a midpoint of BC and E is a midpoint of AC and F is a midpoint of AB. Then AD is the median, B is the median, and CF is another median. So from this AD, BE, and CF are the medians. So every triangle has exactly 3 medians. Every triangle has exactly 3 medians. Here, if D, E, F are the midpoints of sides in triangle ABC, if D, E, F are the midpoints of sides BC, CA and AB, BC, CA and AB respectively, then AD, BE and CF are the medians. AD, BE and CF are the other 3 medians. These are so that we can say every triangle has 3 medians. In triangle ABC, If DF are the midpoints of the sides of triangle ABC, then AD is a median, BE is another median, and CF is the third median. We can observe medians are concurrent. This concurrence of medians is called centroid. Generally we denote with Z. Intersecting point of medians is called centroid. Now let us define centroid. Generally we denote with Z. Centroid also called as center of gravity. Center of gravity Z. Intersecting point of medians is called centroid. Intersecting point of medians is called centroid G of that triangle. And centroid lies on all the three medians. Intersecting point of medians is called centroid. On the other hand, we can say concurrence of medians. Concurrence of medians. Concurrence of medians is called centroid. Centroid Z. That point of concurrence is centroid Z. We can observe centroid G lies on the median AD, and centroid divides that median in the ratio 2:1. That means if AC is 2k units, then ZD is 1k units. If AZ is 2x units, then GD is 1x units. That means AZ is to GD. AZ is to ZD is 2k is to 1k. That means 2 is to 1. AZ is to ZD is equal to 2k is to 1k. That is nothing but 2 is to 1. So we can say centroid divides median in the ratio 2:1. Centroid divides a median in the ratio 2:1. Here in triangle ABC, AD is the median, B is median, CF is the median. So centroid divides each median in the ratio 2:1. So that we can write in triangle ABC, AD is the median, B is another median, CF is third median, as Z is centroid. Centroid divides median AD in the ratio 2:1. That means AZ is to ZD is 2:1. And also BZ is to GE. BZ is to Z is 2 is to 1. And BG is to GE also 2 is to 1. CG is to ZF. Suppose 2x, 1x. CG is to GF. CG is to ZF. It is also 2 is to 1. Now let us write formula for centroid of a triangle whose vertices are x1, y1, x2, y2, x3, y3 is. See, for example, ABC is a triangle with the vertices A x1, y1, B x2, y2 and C x3, y3. Every triangle has a centroid Z. We can find the centroid using these three vertices. Centroid of a triangle is order pair x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. It is centroid of this triangle by using the given three vertices of that triangle. Centroid Z also called as center of gravity. Center of gravity Z formula when three vertices are given and the x1 plus x2 plus x3 by 3. Average of x coordinates of the three vertices gives x coordinate of centroid and average of y coordinates y1 plus y2 plus y3 by 3. That is the second coordinate of centroid. And medians intersecting point. Medians intersecting point. Median intersecting point Z is equal to order by x1 plus x2 plus x3 by 3 comma y1 plus y2 plus y3 by 3. We know centroid G lies on median and if D is a midpoint of BC, then AD is a median. Z lies on AD. So that G divides AD in the ratio 2 is to 1. So we can write that AG is to G, AG is to ZD is a 2 is to 1. AG is to GD is 2 is to 1 and AD is to AZ. AD is to AZ. AD is here AZ 2k units, ZD 1k unit. Then AD is 2k plus 1k, that is 3k units. AD is 3k units and AZ is 2k units. So AD is 3 units, AZ is 2 units, 3 is to 2. AD is to AZ is 3 is to 2. Next AD is to ZD. AD is to ZD. AD is 3k units and ZD is 1k units. That is 3 is to 1. AD is to ZD is 3 is to 1. Next ZD is to AD. ZD is 1k unit and AD is 3 units. 1 is to 3. ZD is to AD is 1 is to 3. Now let us prove centroid formula. If A x1 y1 B x2 y2 and C by 3 are 3 vertices of triangle ABC. Then prove that centroid Z is ordered by x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Let us take a triangle ABC. In this triangle, vertices are given A x1 y1, B x2 y2, and C x3 y3. Given vertices in triangle ABC, given vertices A x1 y1, B x2 y2, and C x3 y3. Let us take D as midpoint of BC. Let D be the midpoint of BC. Then join AD. AD is a median. Then AD is a median. AD is a median. Then AD is the median. We know centroid Z lies on AD and centroid divides AD in the ratio 2:1. If AG is 2 k units, then ZD is 2 k units. Now, it is very clear D is the midpoint of BC. To find midpoint of AB, we use midpoint formula. Midpoint of x1, y1, x2, y2 is x1 plus x2 by 2, y1 plus y2 by 2. Or to x1 plus x2 by 2, y1 plus y2 by 2. The same manner, as D is the midpoint of BC, D is equal to midpoint of BC. As we have B ordered by x2, y2 and C x3, y3, we can write D as midpoint formula x2 plus x3 by 2. Average of x coordinates gives x coordinate of the midpoint. Average of y coordinates gives y coordinate of the midpoint. x2 plus x3 by 2, comma y2 plus y3 by 2. We got D as order by x2 plus x3 by 2 and y2 plus y3 by 2. Now, Z is internally dividing point of AD in the ratio 2:1. Centroid divides median in the ratio 2:1. We know Z divides AD in the ratio 2:1 internally. By using section formula, internally dividing point formula, by applying internally dividing point formula to join of AD in the ratio 2:1, we can find Z. Here we have A x1 y1, D x2 plus x3 by 2, y2 plus y3 by 2. And ratio is 2:1. Ratio 2:1. We know internally dividing point formula. Internally dividing point simply we call as a section formula. Is m1 x2 plus m2 x1 by m1 plus m2, or to pair m1 x2 plus m2 x1 by m1 plus m2, m1 by 2 plus m2 y1 by m1 plus m2. Using this formula, we can find centroid Z. Centroid Z divides join of AD in the ratio of 2:1. For our convenience, compare these 2 points with x1 y1 and x2 y2. A ratio with m1:2 m2. So compare these with x1 y1, x2 y2 and ratio with m1:2 m2. Here x1 is x1, y1 is y1, x2 place substitute x2 plus x3 by 2. y2 place substitute y2 plus y3 by 2. m1 as 2 and m2 as 1. By substituting those values in the formula, m1 is 2, x2 is x2 plus x3 by 2 plus m2 is 1, x1 is x1 by m1 plus m1 value 2 and m2 value 1 is 2 plus 1, comma m1 value 2, y2 is y2 plus y3 by 2, y2 plus y3 by 2 plus m2 value is 1, y1 value is y1 by m1 plus m2, m1 is 2 and m2 is 1. Now let us simplify. 2 ones are 2, so 2 cancel 2 there. Here also 2 ones are 2. Here x2 plus x3 plus 1 into x1 by 2 plus 1 is 3, comma y2 plus y3 plus 1 into y1 by 2 plus 1 3. So we got centroid formula. Centroid Z is equal to write these in order: x1 plus x2 plus x3, x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. There is a formula for centroid of a